there is a surface, that's a horizontal surface, and there is a vertical wall, and two masses are placed something like this, mass m1 and mass m2, and we want to find acceleration of mass m1 and acceleration of mass m2. So this mass m1 is going to move parallel to this contact surface. So let's assume that acceleration of mass m1 is towards left. Let's say it's a1, and this mass m2 is going to move parallel to this contact surface. This is a fixed contact surface, so its acceleration is going to be along this contact surface. So let's assume that its acceleration is a2. So this is a1 and a2 are their accelerations with respect to these fixed surfaces, and these fixed surfaces are actually at rest. Then these acceleration a1 and a2 are basically their accelerations with respect to ground. This is acceleration with respect to ground, and this is your acceleration with respect to ground. These are actually accelerations with respect to these fixed surfaces, and these fixed surfaces are actually not moving. Then these accelerations are with respect to ground. So we are done with acceleration diagram. Let's draw FBD of mass m1. So there is some force m1g acting downwards. This is your earth pulling this particular mass m1, and there would be a normal reaction, say n1, acting somewhat like this. This is a normal reaction due to ground, and then you have another normal reaction n from this contact surface between the two bodies. So this is going to be perpendicular to this particular surface, and its acceleration diagram is a1. Now we can choose two axes. Let's assume one axis is this and other axis is this. Resolve all the forces and accelerations in these two particular axes. Then this angle is theta. So you can say this is going to be n cos theta, and this is going to be n sin theta. And we have resolved this particular force n. So in x-axis we basically have an equation that n sin theta is equal to m1a1. This is your first equation. In y-axis there is no acceleration in y-axis, so we can say we can apply force balance in y-axis. So y-axis we have m1g plus n cos theta equal to n1. This is the second equation for first body. Now draw FBD of mass m2. So there is force m2g acting vertically downwards. This normal is going to act in this particular direction. This is your normal reaction due to mass m1 to m2, and there is another normal reaction from the wall. It's going to be, say, n2. Acceleration of this mass m2 is vertically downwards, a2. So we can choose two axes. Let's say one axis is this x-axis and this vertical axis is, say, y-axis. Now resolve all the forces and acceleration in these two particular axes. Now this angle is going to be theta, so we can say this is going to be n cos theta, and this is going to be n sin theta. Now we can remove this n. For x-axis there is no acceleration of mass m2. We can apply force balance in x-axis. So we have something like n sin theta is equal to n2, and in y-axis net acceleration is vertically downwards, and that acceleration is a2. So net force in y-axis should be equal to ma2. So m2g minus n cos theta is equal to m2 a2. So this is our fourth equation. Now let's see how many unknowns are there and how many equations we have got. We have got 4 equations, and unknowns are a1, a2, n1, n2 and n. We have 5 unknowns, so there is something we are missing out. We need one more equation. We need one more equation. So this basically fifth equation comes from constraint equation. This is a constraint equation that these two bodies are constrained to move along this particular contact surface. So we have something like constraint equation and our accelerations of the bodies are something like a1 and a2. Now if there is an observer on this mass, then motion of m2 with respect to this observer is along this direction. So this observer on m1 sees m2 moving along the incline. So relative acceleration of m2 with respect to m1 is going to be parallel to this contact surface. Acceleration of m2 with respect to m1 is along the contact surface. Which contact surface? Contact surface between the two bodies. So we have something like acceleration of m2 with respect to m1 is basically acceleration of m2 minus acceleration of m1. Acceleration of m2 is a2 vertically downwards minus acceleration of m1 is a1 towards right. So this is acceleration of m2 vector and this is minus of acceleration of m1 vector, and the resultant is basically your acceleration of m2 as seen by m1, and this should be along the incline. Now if this is along the incline, this angle was given to be theta, so this angle should be theta. This angle, let's look at it again. This angle is given to be theta, therefore this angle has to be theta because this line is along the incline. So we can say tan theta is equal to a2 by a1. Now this is your fifth equation. So now we have 5 equations and 5 unknowns. We can solve and get the answer.